Okay, for those of you that are just now tuning in, sorry we forgot to turn on the camera. So here's where we're at. The time up, 1.22 seconds. I'm going to give the very condensed version. 1.22 seconds, that had to be more than 1 second because the initial velocity was more than 9.8. Then on the max height, we use that equation, v squared minus v naught squared over 2a. Notice that you have a negative number in the denominator. That's what I expect to see, whether you go straight to negative 19.6 or you just use negative 9.8. That's what I expect to see. Now, on the time down, this is what this is exactly what I would have done to find the time down. It's simple, it's elegant. Oh, it's just because on the time down, what's your initial velocity? 0. Because me dropping this ball from 15.35 meters high is the exact same mathematically as me throwing the ball up, reaching a height of 15.35 and starting to fall. Okay? Because in both situations, the velocity starts at 0. That's an important conceptual idea to understand. All right. Now, here's what's cool, what Shannon did. Notice that I've got 2 negatives underneath that radical. I'm going to look for that on this problem. So let me give you all a hint. When I tell you, like this is going to be the last problem on the test, I write the tests, right? Trust me. It isn't like I walk in tomorrow morning and somebody else has written the test for my class and I look at the last problem and go, oh man, I didn't prepare him for that question, okay? I write the test. When I tell you this is going to be the last question on the test, I'm not bluffing, okay? It's going to be the last question on the test. It's going to be worth more points than any other problem on the test. And when I tell you this is what I'm going to look for in terms of quality of work, that's what I'm going to look for, okay? Now, the velocity on the way down, Franny. We need to tweak this in one small way. What do we need to tweak it as? It needs to be negative. Why?
Because it's going down.
Because it's going down. If you left that velocity as positive 17.34, which direction do I think the ball was going? I think the ball was going up. Okay? Now, is there another way that you could have found the final velocity? Could you have used V equals V naught plus AT? On the way down, what's your initial velocity? 0. Do you know your acceleration on the way down?
Yeah.
Negative 9.8. Do you know how long it falls from 0? 1.77. So this is actually a little bit easier because that's just negative 9.8 meters per second squared times 1.77 seconds. Okay?
Mathematically, do I just need to know it should be negative?
Huh?
Do I just need to know it should be negative? Okay.
Because your velocity, if nothing else, look at your velocity time graph. You know it has to end up being a negative value. So the beauty of this one, if you use the V equals V naught plus AT, that automatically generates the negative velocity. And then you don't have to think about it. All right. So when you draw this graph, and yes, you're going to draw a velocity time graph on this problem. If you find yourself making your velocity time graph do something like this or something like that, where that slope changes, why is that problematic?
Gravity changed.
You're telling me the gravity changed. Gravity became stronger on the way down, or gravity was weaker once it started to fall. When you draw this graph, if you don't have the same slope the entire time, you have done something horribly wrong. Okay, that's going to be the last problem on the test. Second to last problem on the test is going to involve a rocket sitting on the launch pad. What do you think the initial velocity of the rocket is going to be sitting on the launch pad? 0. So we're going to fire the engines. On the rocket problem, and this is going to be important, on the rocket problem, your velocity time graph is going to start at 0. you're gonna fire the engines. What's the velocity going to do? Hopefully,
Increase.
increase. If it doesn't, that was an epic failure. So you're gonna go something like this. So this would be like me taking the ball and throwing it, okay, while it's in contact with my hand. So what's gonna happen is that I'm gonna give you some information up here. I might say the final velocity of the rocket is, I don't know, say 50 meters per second. I might tell you that it's like a certain height, like maybe it's, I don't know, 10 meters above the ground, or I'm gonna tell you that it took 5 seconds to do that, something like that. And you should be able to calculate the acceleration of the rocket based upon the information that I give you, the initial velocity, the final velocity, and then I'm either gonna give you distance or I'm gonna give you time. Find the acceleration. At that point, you're gonna shut off the rocket engines. That's like me throwing this ball up in the air. As soon as I shut off the rocket engines, or if this ball leaves my hand, what's the only force acting on it?
Gravity.
What's the acceleration gonna be? So this is when I shut off the engines. So what's the graph gonna do?
Go down.
What's gonna be the value of that slope?
Negative 9.8.
When the rocket reaches that point, where's it at?
It's peak maximum.
At its maximum height. Why? The velocity equals
Zero.
0. So you went from positive acceleration from the rocket engines being fired, that's like me throwing this thing, to coasting to a stop at its maximum height. Then what's the graph gonna do?
Go down.
Because then the rocket is falling back down to Earth, okay? If you get done tomorrow with the velocity time graph on the rocket, if you haven't drawn something that looks like a roof, you've done something horribly wrong, okay? I'll tell you straight up. This is gonna be the second to the last problem on the test. So here's the second to the last problem on the test, rocket problem. Last problem on the test, ball off the building problem, okay? Now, especially in the spring, or excuse me, in the fall, to get you ready for the test, I'm gonna give you some various bits of information. One is going to be a list of topics that you need to know for the test, okay? Now, if yours happens to say 6 through 10, it's just because the program renumbered it. If you got the top half of this, it says 1 through whatever, this says 6 through 10, don't worry about it, it's all the same information, it's just the numbering is a little bit off. So these are just things you need to know, okay? Don't flip out. This is a blank set of problems, okay, that you need to know. If you do nothing else, you work 8 and 9. 9 is a similar type problem as the rocket. You're just shooting a bow up in the air, okay? So conceptually, number 9 and the rocket problem are identical, okay? 10 is where you're standing on top of a bridge and you throw the rock and it's gonna fall back down. The only thing I can do on these problems is change the numbers, okay? Literally, that's the only thing that I can do. I can make the bridge higher, I can make the bridge lower, I can make the velocity faster, I can make the velocity slower. That's all I can do. If you have time, I would suggest you work these problems at least a couple times, but change the numbers. Now, you're also going to be given the answer key, so you'll know exactly if you did the problems right. I would not breathe on this, okay? Don't look number 8, go, okay, hey, what's the maximum height? And then look at mine and go, oh, that's exactly how I worked at 2 Brookcamp, that's cool. And then you go time, oh yeah, I'd have done that exact same thing, promise you, okay? No! Use this as like a sacred answer key, right? Hide it. Only look at it when you think you've worked it. Now, if you're on a problem and you go, God, I have no idea how to do this problem, and you need a hint, hey, give it a look, okay? But especially if you do nothing else, work 8 and 9. 9 is like the rocket problem, 8 is the ball off the building problem, okay? So you're gonna get the list of the topics, and then the answer key to that. Good luck. And don't forget tomorrow, you can stay late and continue to work on the test. Go to that meeting, you can back. I have no idea what happened.
How late is too late? How late is too late?
Yeah, we're cooking breakfast. That's a little late.
You didn't do the
If you're texting mom to bring jams, yep. Huh? The laminated version of it. You won't have yours. Yeah, you will have a laminated version of the yellow equation sheet for the test. The other thing that will happen if you want to begin to decide who's going to move during testing, you're only allowed to have one person per table. So one person can go to the back, move the other tables up here, but you're only allowed one person per table. So you rock, paper, scissors, get a coin,
I'm not using it until I'm done.
Yeah, of course you check them every problem, it'd be so easy.
It'll be your middle and no between. I gotta give it consistency. This is what it does. Because like this one I can actually get the last one was like I know. I feel like
About the first 20 questions of the test will be multiple choice, and we got big problems to work out after that.
Would you say like, it's pretty